Right, so inverse functions. So to give us a little context, I would like to talk about these two functions that I have on the screen right now. F of x equals x plus 4 and g of x equals x minus 4. And notice that f takes whatever number you plug into it and adds 4 to it. G does the opposite. It takes whatever number you plug into it and it subtracts 4 from it. So for example, f of 5 is 5 plus 4, which is equal to 9. And g of 9 is 9 minus 4, which is equal to 5. So if we were to graph the line f of x equals x plus 4, it would go through the point 5, 9. And if we were to graph the function g, it would go through the point 9, 5, right? Because this is the input was x, the output y. Input x, output y. All right, so since one function does the opposite operation of the other, you get this characteristic that on one function you have a pair of coordinates and on the other function you have that same pair but reversed. All right, another thing that happens in this situation is interesting when you take the composition of the two functions. So let's look at g composed with f of 5 there. G composed with f of 5. So remember we learned about compositions that immediately, instead of using the Fogg and Goff notation, rewrite it in the regular parentheses notation. So g of f of 5. All right, now g of f of 5, you work on the innermost parentheses first like usual. What did we already say that f of 5 is equal to? 9, that's right, good. So that means that we're really taking g of 9. But what did we already say that g of 9 is equal to? 5, good. So note with 5, and we ended with 5. Now let's look at f composed with g of, actually let's do f composed with g of 9, not 5. F composed with g of 9. All right, so we're going to immediately rewrite it in the different notation. It's going to be f of g of 9. Now, but working from the innermost parentheses first, what did we get when we plugged 9 into g, in other words? Can you guys hear me? Good, 5. Okay, so that's going to be f of 5. And again, f of 5 turned out to be 9. So notice that when we started with 9, we ended with 9 there. In fact, in general, if you take g composed with f of x, let's see what we get with x's in it. So that's going to be g of f of x. But what is f of x equal to? Looking up here on the top left, what is f of x equal to? X plus 4, good. So inside those parentheses, I'm going to replace f of x with what it's equal to, x plus 4. Okay, now this is telling us we want to take x plus 4 and we want to plug it into g. And remember what g does is it takes whatever we plug into it and it subtracts 4 from it. So if we're plugging x plus 4 into g, then we're going to get x plus 4 minus 4. And what does that simplify to? Just x, that's right. So notice whatever we started with here is what we ended up with. And so it turns out that these two functions, f and g, are examples of what we call inverses. They're inverses of each other. In fact, we normally would probably give them the names f of x is x plus 4, and in order to indicate that g is actually the inverse, we would not call it g, we would call it f inverse of x. This is read f inverse of x. Now, I'm admitting that this is a terrible notation, because you might recall that if you take a number to the -1 power, that's telling you to flip it over. And that has nothing to do with what's happening here. that negative 1 power is not referring to this. It doesn't have the same meaning here. Whenever it's next to a function, that means f inverse. So it's unfortunate that we didn't come up with a different symbol, but we're stuck with it now. So anyway, we're going to be studying functions that are inverses, and this characteristic that when you plug anything into its composition, you get that same number out is important, because this is how we'll test to see if f and g are inverses. Anytime we have two functions, we can calculate f composed with g of x and g composed with f of x. And if we get x both times, then we know that f and g are inverses of each other. Okay, now hopefully you guys are taking notes, by the way. If your learning style includes taking notes in class, then you should be taking notes during this class, even though I'm not sitting in the room with you. It's still gonna help you to process the information. Oh, good question, Mauricio. In order to test if f and g are inverses, it has to work in general. So it can't be just one particular number. You have to use the x to represent a variable, any value. So when you do the test, you're going to be using x's, not a particular number. But it is true that if they are inverses, then no matter what number you put in, you'll get the same number out. It's just that if you want to test to see if they're inverses, you have to use x, not a particular number. Because it is possible for two functions to coincidentally have this characteristic at a particular value, but not have it at all values. So by using x, we see that it works for any number. Okay, so now we're going to apply this idea. So one type of problem that you will see is you'll be asked to determine if two functions are inverses of each other. This is a little sloppy, so I'm just going to rewrite it here. So we want to determine if f of x equals 2x plus 3 and g of x equals 1/2 x minus 3 are inverses. And the test for that is you find Fogg and Goff, f composed with g of x and g composed with f of x, and we see if we end up with an x. Okay, so let's go ahead, and I'm going to do the first one with you, and then you will do the second one for a minute and see what you get. All right, so Fogg, f composed with g of x is what that is. And we want to work from the inside out, so I'm going to replace g of x with what it's equal to. What it's equal to is 1/2 x minus 3. Oh, by the way, you might want to kind of eyeball these two functions and see if you think they might be inverses. Remember, inverses do opposite operations. So like here, f is multiplying 2 times x and then adding 3 to it, and g is taking half of x and subtracting 3. So it's reasonable to think these might be inverses because they appear to have opposite operations. Opposite of doubling something is taking half, and opposite of adding 3 to something is subtracting 3. All right, so anyway, we're going to replace g of x with what it's equal to, 1/2 x minus 3. And now we're going to plug into f. Now, what does f do to anything we plug into it? We're going to plug, let me use a different color here. We're going to take this and we're going to put it in where we had an x. It's going to be 2 times that expression plus 3. So this is going to be 2 times 1/2 x minus 3 plus 3. You see, we've replaced the x with the 1/2 x minus 3. All right, now I'm going to distribute through the parentheses. 2 times 1/2 x is just going to be x. 2 times -3 is -6. And then plus 3. Now I'm going to combine like terms, then we're going to get x minus 3. So is that equal to x? No, this is not equal to just x. Okay, so that's important because what this tells us is that f and g are not inverses. You have to get just an x, and it has to work for both Fogg and Goff. Now, I already know they're not inverses, but I just want you to practice because you know people have trouble with compositions. So I want you to go ahead and at home right now on your piece of paper, write out Goff. Go ahead and do g of f of x and see what you get for that one. So just take a minute. Good question. I got x minus 6 by distributing the 2 through the parentheses. 2 times 1/2 x, 2 times 1/2 is 1, so you just get x. And then 2 times negative 3 is negative 6. So I got x minus 6. Did that answer your question, Megan? I'm going to pull you in just a minute to see what you got. So, okay, it looks like you guys are finishing up. So here we go. So we're going to replace f of x with what it's equal to, which is 2x plus 3. And then we're going to take that 2x plus 3 and we're going to plug it into g, replacing x with that quantity. So we're going to have 1/2 of 2x plus 3 minus 3. Okay, so now we're going to distribute the 1/2 through the parentheses. 1/2 times 2x is just going to be x. 1/2 times 3, thinking of it as 3 over 1, and multiplying straight across, we'll have 3/2. And then we're going to do minus 3. All right, 3/2 minus 3, you're going to have to, you could use the fraction function on your calculator, but just to remind you to do this by hand, think of it as 3 over 1 and get a common denominator. So 3/2 minus, we're going to multiply by 2, so we're going to get 6/2. 3 minus 6 is negative 3, the 2 stays the same. So this is x minus 3/2, which again just demonstrates that those two are actually not inverses.
I hope you found this video useful. If you did, please remember to like it.